Welcome to the deep dive, everyone. And I want to extend a massive, very specific welcome to you, the listener.
Absolutely.
And today we're giving a really intentional shout out to the young students from Edward Little High School.
Yes, specifically the ones currently walking the Sigma Scholar academic pathway. Welcome.
Right. Welcome to the deep dive. This exploration today is meticulously engineered for you. You are, the ambitious learners looking to bridge that massive and, let's be honest, often terrifying gap between hard, undeniable technical skills and the interpersonal excellence that you genuinely need to thrive inside modern industry teams. Because look, if you take a brilliant computer scientist who can write flawless million-dollar code and you put them in a room to negotiate a complex team dispute,
Oh, it's bad.
it is. There is a shockingly high statistical chance that the entire project will just crash.
Yeah, it's a strange paradox, isn't it? I mean, we spend years optimizing algorithms to run at blistering speeds, perfectly handling edge cases, syntax errors, all of that. Yet the very moment we step out of that icy, climate-controlled server room and walk into the messy, open-plan team space where the actual humans are building the software,
Yeah.
that whole expectation of mechanical precision just completely shatters.
Which is exactly why we are looking at this today. We're looking at the invisible manual for human servers, basically.
I like that, yes. It really is the ultimate engineering challenge because the machines you build, they come with meticulous documentation.
Right.
If a server goes offline, a red light blinks,
Right.
right? Diagnostic logs isolate the failure, and a sysadmin can point directly to a faulty logic board.
Exactly.
But the humans, the ones communicating with each other to design those systems, they do not have error logs. The human ecosystem is fluid, it's unpredictable, and it's infinitely more complex than any code base.
So to help us sort of visualize this today, we are going to follow the journey of two legendary, aspirational figures in our Sigma Scholar universe.
Big Sig and Lil Siggy.
Yes. Big Sig and Lil Siggy. These are our exemplary personas, kind of the ultimate North Stars for an Edward Little student.
Right.
Because Big Sig and Lil Siggy flawlessly navigate highly stressful technical environments. But here's their secret. They don't succeed just because they can run complex algorithms.
Right.
They succeed because they treat human communication as a design problem.
Oh, that's such a great way to put it. They speak a very specific dialect with their peers, you
Yeah.
know? They obsessively manage their own cognitive load, and they design their daily interactions for maximum empathy.
Yeah. They recognize a fundamental truth that, honestly, a lot of engineers ignore until it's way too late.
Which is that human brains are not microchips.
Exactly.
Human conversations are not command line prompts.
Yeah.
You just cannot brute force a relationship the way you can brute force a password.
So what is their playbook? How do Big Sig and Lil Siggy actually do this in practice? Well, over the next hour or so, we are going to unpack a really fascinating stack of research.
Oh, we have some great sources today.
We really do. We're pulling from the origins of hacker linguistics, examining behavioral economic studies on human scarcity.
Mullainathan and Shafir, yes.
Right. And we're digging into the biological constraints of user experience design. And finally, we'll look at how computer data structures can literally be used as blueprints for emotional intelligence.
I love that part.
So let's just jump in. Let's start with the scenario. Imagine Big Sig and Lil Siggy are working on a massive piece of software. Let's call it the Inventory API project.
Okay, setting the scene.
Yeah. Midterms are looming at Edward Little. The deadline is in 48 hours, and the pressure is just immense. Now, when you listen to them troubleshoot in the lab, you start hearing something strange. Mathematical operators and networking terms are suddenly bleeding into their casual verbal conversation.
Right. And what you're observing there is a sociolinguistic phenomenon known as semantic migration, or lexical broadening.
Semantic migration.
Yeah. It happens when highly specialized, microscopic terminology from STEM fields, science, technology, engineering, math, when that crosses the boundary into everyday speech,
Okay.
the terms become vernacular, but they drag the ghost of their original, incredibly precise technical meaning along with them.
And this isn't just a random trend, right? Like, if we look back at the history, this urge to talk like a computer started in a very specific place.
It did, yeah. To understand why Big Sig talks the way he does, you really have to mentally travel back to the late 1970s and early 1980s.
Okay, take us back.
Picture the elite computer science laboratories of that era.
Right.
The MIT AI Lab, the Stanford AI Lab,
Yep.
Carnegie Mellon.
Right.
These environments were intense. I mean, you had Brilliant early programmers practically living in these labs, fueled by terrible coffee.
Probably out of vending machines, yeah.
Exactly. And they're working on these massive PDP-10 mainframe computers. And out of this hyper-focused nocturnal culture came a document called the Jargon File.
The Jargon File.
Yeah, it was a collaborative, constantly evolving dictionary of the slang these engineers invented.
But, calling it slang almost feels wrong. When I think of slang, I think of words that are loose, cultural, maybe even a little ambiguous. This was like the exact opposite of that.
Oh, completely. Linguists actually categorize this as precisionist English.
Precisionist English.
Right. Think about what these people were doing all day. They were writing logical instructions that had to be absolutely flawless.
Right, because if you miss a single semicolon.
The entire system crashes. The machine is utterly unforgiving.
Wow, yeah.
So when these engineers turn their chairs around to talk to their human colleagues, about getting lunch or fixing a bug, they brought that intense desire for absolute logic with them.
They started verbing nouns.
Exactly. They started using mathematical operators to describe their social lives. They just wanted to communicate highly abstract, complex thoughts using the rigorous frameworks they used for coding.
Okay, let's look at one of the most famous examples of this semantic migration. It's a word that Big Sig and Lil Siggy use constantly during this inventory API project. The word is modulo, or just mod.
Yes. Modulo.
Now, if you are sitting in a discrete math class at Edward Little High School, you are going to learn the formal academic definition of this. And I want to make sure we truly understand the math before we look at the slang. So let's start with the classic analogy.
The best way to visualize the formal modulo operation is clock math.
Oh, clock math, okay.
Yeah. Imagine a standard 12-hour analog clock. If it is 10 a.m. and you add 4 hours to the time, you don't say it is 14 o'clock.
Well, unless you're using military time, but sure.
Right, but on a standard analog clock, you say it's 2 p.m. In a modulo 12 system, once you hit the number 12, you wrap back around to 0. The modulo operation is essentially finding the remainder of division. If you divide 14 by 12, the remainder is 2.
Okay, that makes perfect intuitive sense.
But mathematically, it goes deeper into something called equivalence classes.
Okay, you're losing me a bit. What is an equivalence class?
In modular arithmetic, numbers that leave the same remainder are placed into the same equivalence class. So let's shift to a modulo 4 world.
Okay. Modulo 4.
The numbers 1, 5, and 9 are functionally identical in this world.
Because if you divide any of them by 4...
You are left with a remainder of 1.
Right, okay.
So in the eyes of a modulo 4 system, the differences between 1, 5, and 9 are entirely irrelevant. They belong in the exact same bucket.
Okay, so how on earth does a concept about equivalence, buckets, and remainders turn into something you say in a project meeting?
Well,
Because, if I tell my mom, my room is completely clean, modulo the giant pile of laundry on the chair, she isn't going to marvel at my precision. She's going to tell me to pick up my socks.
right.
It just feels like overcomplicating the phrase, except for...
And in your bedroom, it absolutely is overcomplicating it. But in a highly technical environment, using a word like modulo provides a crucial asset, and that is semantic density.
Semantic density.
Yes. It is about packing a massive, multi-layered concept into a single word. Saying modulo isn't a pretentious way to say except for. It is a highly efficient algorithm for language.
So when Big Sig is reviewing Lil Siggy's code for the inventory API, and he says, this new software build is fully functional, modulo that weird bug in the payment gateway, he is doing way more than just pointing out an exception.
Precisely. He is invoking the mathematical concept of equivalence classes.
Oh, wow.
He is telling her, if we take the payment gateway bug, put it in the remainder bucket, and completely ignore it, the entire rest of the code base is in the exact same state of perfection as our baseline. They are mathematically equivalent.
That partitions the discussion instantly.
Exactly. It tells little Siggy exactly what variables to hold constant in her mind and what variables to isolate. Two people who share that mental map can instantly align their focus without spending 5 minutes clarifying what is and isn't working.
It's an incredible linguistic shortcut.
It really is.
And there are other terms that have migrated the exact same way. Let's look at orthogonal. Because if I am trying to fix an API under a deadline, I want my team's efforts to be orthogonal. Let's break down the geometry of that one first.
Sure. So in geometry and linear algebra, two vectors are orthogonal if they intersect at a perfect right angle.
Okay.
More technically, their dot product is 0. Imagine an x-axis and a y-axis. You can move infinitely far along the x-axis, and your position on the y-axis never changes.
Because they're entirely separate.
Right. They are structurally fundamentally independent of one another. In computer architecture, an orthogonal instruction set means you can swap out registers without them ever interfering with each other's operations.
But when Big Sig uses it, he's talking about people and problems, right? He might say, the backend database issue is orthogonal to the user interface glitch.
Right. And notice why that is vastly superior to just saying the issues are unrelated.
Because unrelated is vague.
Exactly. It just means there is no obvious connection. But saying they are orthogonal implies a structural independence. It means, Lil Siggy, you can completely rewrite the database logic, and I guarantee it will not affect the interface design I am working on. We can work in parallel without stepping on each other's toes.
Oh, I love that. It establishes this really low-context, high-trust environment.
Yeah, it does.
And then there's delta. That's another big one. The Greek letter used in physics to represent a finite change in a variable. You know, the change in temperature, the change in velocity.
And in the industry, it has become the absolute standard term for the quantifiable difference in states. A project manager won't ask, did the update help?
No.
They will ask, what is the delta for our processing speed?
Yeah.
They're demanding a specific unit of change between the before state and the after state.
I see why this is so critical for the students at Edward Little High School to grasp. When Big Sig and Lil Siggy use terms like modulo, orthogonal, and delta, they aren't just showing off their vocabulary.
No, not at all.
They're signaling in-group credibility. They are using a shared dialect that strips away ambiguity, it compresses complex logic, and it allows them to navigate massive problems rapidly.
It is the ultimate tool for efficiency.
Yes, and that brings up a massive question. Why are these elite engineers so utterly obsessed with linguistic efficiency? Why the desperate need to save a few seconds in a conversation?
It's a great question.
Well, if we look at behavioral economics, it turns out they aren't just trying to save time. They are trying to save their most precious, rapidly depleting biological resource. They were trying to protect their mental bandwidth.
This is a profound shift in how we understand human capability.
Yeah.
Because the term bandwidth originated in pure telecommunications.
Yeah.
It literally describes the physical width of a pipe.
Right, like an internet cable.
Exactly. It's a measure of data transfer speed, calculated in bits per second or hertz. It dictates how much information can flow through a network cable at any given millisecond.
But we hear it constantly in offices now. You know, I don't have the bandwidth to take on that project, or my bandwidth is totally fried today. It has been completely co-opted.
Because it perfectly describes the biological bottleneck of the brain. When cognitive psychologists and behavioral economists, specifically Senthil Mullainathan and Eldar Shafir,
Right.
when they began studying human attention, they applied this telecom term to cognition. Mental bandwidth is defined as the absolute finite cognitive capacity available for a human being to process information, make logical decisions, and crucially exercise self-control at any given moment.
Finite. That is the terrifying word there. It's not a muscle that you can just push through if you try hard enough. It is a battery that drains.
And Mullainathan and Shafir discovered exactly how quickly it drains when they studied the concept of scarcity.
Oh, the study is wild.
It's fascinating. They conducted real-world experiments. One of their most famous studies involved sugarcane farmers in India. Now, these farmers experience a drastic financial cycle. Right before the annual harvest, they are incredibly poor. They are experiencing intense financial scarcity. But right after the harvest, they're relatively wealthy.
So they tested the exact same people under two different conditions.
Exactly. They gave these farmers cognitive tests. Tests like the Stroop test, which measures impulse control, and Raven's progressive matrices, which measures fluid intelligence.
In the results?
Staggering. Before the harvest, when the farmers were experiencing severe financial scarcity, they scored significantly lower. In fact, the drop in cognitive function was equivalent to losing about 13 IQ points.
Wait, 13 points?
Yeah, or the equivalent of losing an entire night of sleep.
Wait, so their actual functional intelligence dropped simply because they were worried about money? How does the biology of that even work?
It is entirely biological.
Yeah.
Scarcity, whether it is a lack of money, a lack of time before a midterm, or a lack of focus due to chaotic project management. It creates what researchers call a tunneling effect in the prefrontal cortex. The brain perceives the scarcity as a survival threat. It hyper-focuses your working memory and your attention entirely on the immediate crisis. It's a biological override.
So if you were tunneling on the crisis, you have literally zero bandwidth left to spend on anything else.
Precisely. It was a bandwidth tax.
Huh.
If your brain is spending massive amounts of glucose and cognitive energy constantly calculating how to survive the deadline, you have less energy to decode complex information.
Right.
You have less energy to solve lateral problems, and critically, less energy for emotional regulation.
Wow. Let's apply this directly to our Sigma scholars. Remember the inventory API project?
Yeah.
Let's say Big Sig is just exhausted. He has 3 massive AP exams tomorrow. He worked a late shift at his part-time job, and the API is fundamentally broken.
A high-scarcity environment.
Exactly. Lil Siggy walks over and asks a relatively simple question about the database structure. Big Sig instantly snaps at her. He is short. He is dismissive. He is completely out of character. Now, as an outsider, you might look at that and think, wow, Big Sig is a jerk, or maybe he's just not cut out for the pressure.
And that is the fundamental attribution error that destroys teams. We confuse a dynamic state with a fixed trait.
Explain that.
Big Sig's fluid mental bandwidth is fundamentally different from his fixed IQ or his core personality. When he snaps at Lil Siggy, it isn't because he lacks intelligence or empathy.
No.
It is because the cognitive resources required to pause, formulate a polite response, and regulate his tone of voice have been entirely depleted by the scarcity tax of his midterms and the failing code.
His battery is dead.
His biological CPU is running at 99% capacity, just trying to survive the stress. When Lil Siggy's question introduces a new process, his system simply lags and crashes.
That is such a vital reframing for anyone working in a high-stakes environment. Now, I know there is some debate in the academic community about ego depletion, this idea that willpower is a strict, easily drained resource. I've read some newer studies suggesting willpower might also be tied to our beliefs about it.
That is true. The specific mechanics of ego depletion are heavily debated right now, particularly whether, a sugary drink can instantly restore willpower, as older studies claimed.
Right, the lemonade study.
Exactly. However, the overarching reality of cognitive load is universally accepted. Constant context switching, intense stress, and decision fatigue absolutely drain your ability to process information effectively.
Decision fatigue is so real.
Think about decision fatigue in a grocery store.
Oh, the worst.
If you stare at a wall of 50 different types of cereal, evaluating the price per ounce, the sugar content, and the fiber of every single box,
Yeah.
you're burning immense cognitive calories.
Yeah.
By the time you reach the checkout, your prefrontal cortex is so tired that you impulse buy a candy bar. Your self-control is gone.
So how does a Sigma scholar combat this? If an Edward Little student wants to be like Big Sig and Lil Siggy, who obviously experienced the exact same midterms and coding bugs as everyone else, how do they protect their bandwidth?
Well, a true industry leader recognizes this biological limitation and actively builds systems to defend their bandwidth.
Like what?
They automate routines so they never have to make trivial decisions. They wear similar clothes, eat predictable meals, and follow strict morning protocols.
Like Steve Jobs with the black turtlenecks.
Exactly. They establish distraction-free environments, ruthlessly silencing non-essential notifications.
Yes.
Because every single buzz of a phone forces the brain to context switch, which burns a fraction of their cognitive battery. And they understand that protecting their teammates' bandwidth is just as important as protecting their own.
Which brings us to the actual design of the digital world we live in. Because if human bandwidth is this incredibly fragile, this easily taxed by just existing in a complex environment, then the software we build and the way we structure our workflows must desperately accommodate it.
Absolutely.
We cannot design team protocols assuming humans are infinite processors. We have to design for the biological delay.
And this takes us directly into the realm of user experience design, specifically the pioneering work of Jakob Nielsen.
Jakob Nielsen.
Yes. Nielsen introduced a profound framework called ThinkTime UX, anchored by what he calls the Chronosapien Compact.
Chronosapien Compact? I mean, it sounds majestic, almost like a sci-fi treaty.
It does, but it is deeply grounded in human neurobiology. Nielsen argues that we must design systems that respect the reality that humans are chronosapiens. Meaning we are creatures uniquely bound by the biological constraints of time. We experience time across multiple highly distinct psychological scales.
Okay.
And Nielsen points out a massive irony in modern computing. We spend billions of dollars making server responses infinitely faster, but the biggest bottleneck in any technical system is no longer the machine.
Wow.
The server can fetch a database query in 5 milliseconds. The bottleneck is human cognitive latency.
Cognitive latency. Walk me through the mechanics of that. Because latency usually just means lag, right?
Right. Cognitive latency is the biological delay between the moment a system presents information and the moment the human user actually comprehends it and takes meaningful action.
Give me an example.
Imagine an analytics dashboard. The system renders a complex graph showing a drop in sales in under 3 seconds.
Which is incredibly fast compute time.
Exactly. But the human user sits there for 15 seconds staring at the axis, trying to understand what the colors mean.
Right.
Then they spend another 30 seconds debating whether to email their boss or investigate the raw data. The real latency of that interaction isn't 3 seconds. It is 48 seconds of human processing delay.
We get so frustrated with the spinning wheel on our screen, completely ignoring the fact that our own brains are the slowest components in the entire loop.
We're the ultimate bottleneck.
Mm.
And to help designers fix this, Nielsen meticulously deconstructs human interaction into 5 distinct biological phases. He calls it the cognitive latency stack.
Okay, let's break this stack down, because this is directly applicable to how we communicate with each other, not just how we build software. Phase 1 is perception.
Perception occurs in the 0 to 400 millisecond range.
Yeah.
This is purely sensory. It is the visual cortex detecting a change in the environment.
Okay.
If you click a button on a web app, your brain needs to see a state change within 400 milliseconds, or it assumes the action failed.
That is the exact reason why when I double tap a post on Instagram, the little heart icon bounces instantly.
Yes.
If the network is slow and the heart doesn't bounce in that tiny fraction of a second, I instantly assume it didn't register. So I tap it 3 more times and then I accidentally unlike the photo. It's infuriating.
That is a perfect example of a system failing the perception phase. The system must provide a visual receipt, a shadow, a color shift, a bounce that says, I physically heard your command.
Okay, so that's phase 1.
Now, phase 2 is comprehension. This happens in the 0.4 to 2 second window. You saw the visual change. Now your brain has to grasp what it functionally means, ideally without engaging the slow, calorie-burning process of reading a paragraph of text.
Like those tiny toast notifications that slide in at the corner of your screen saying email sent.
Exactly. It is outcome first. You comprehend the success instantly without dedicating any real mental bandwidth to decoding it. Then we hit phase 3, decision. This takes roughly 2 to 10 seconds. You perceive the state change, you comprehend what happened, and now you must choose your next action.
And this is where the bandwidth tax really hits, right? Because if the system gives me 15 different ways to proceed, I just freeze.
Yes. Hicks' law in UX states that the time it takes to make a decision increases with the number and complexity of choices. If a system demands a complex decision in this phase, it burns cognitive calories. This is why brilliant designers use smart defaults. They pre-select the most statistically likely next step so the user can just hit enter and move forward without deep thought.
Okay, what happens if the system needs more time? What if it's processing a massive video file or something? That moves us into phase 4, which Nielsen calls the danger zone.
Right. Phase 4 is execution. This is any wait time from 10 seconds to a minute or more. Neurobiologically, if a human is forced to wait passively for more than 10 seconds, their attention physically drifts.
Oh, for sure.
We cannot maintain focus on a static progress bar. We open a new browser tab. We check our phones. We pivot to a new task. Elite systems handle the execution phase by running heavy tasks in the background and freeing the user to do other things rather than holding their attention hostage.
And when they finally come back from checking their phone, or maybe they come back the next morning, they hit phase 5.
Recovery. This could be minutes, hours, or even days later. Your attention drifted, your context was lost, and now you have to re-engage with the system.
That's the hardest part.
The cognitive latency here can be disastrous. How long does it take you to remember what you were trying to do? How much mental energy do you waste reorienting yourself to the interface?
This makes me think about the tools Big Sig and Lil Siggy are using right now. We are living in the explosion of generative AI.
Oh, yeah.
We have large language models that generate code, write essays, build images instantly. If everything is moving toward instantaneous generation, shouldn't we just focus entirely on making the servers faster and totally eliminate this wait time?
You would think so, but that is the most dangerous assumption in modern technology. It's completely backwards. Our sources emphasize that AI actually drastically increases cognitive latency variance and human interpretation overhead.
Wait, how? I mean, it writes a 10-page report in 5 seconds. That is literally removing latency.
It is removing machine execution latency, but it is exploding human comprehension latency.
I see.
Because AI is probabilistic, not deterministic, its outputs are wildly variable. A database query is predictable. AI is not. Generating a simple summary might take 2 seconds. Generating a complex multi-layered data visualization might take 4 minutes.
Right.
That unpredictable variance creates profound uncertainty in the user, which burns bandwidth. But far more critically, interpreting an AI output requires immense, exhausting human effort.
Ah, because it might be lying to me. It might be hallucinating.
Precisely. The AI generates a 10-page technical report in 5 seconds, but it takes the human engineer 20 minutes to read it, verify it for hallucinations, cross-reference the citations, and decide if the logic is actually sound.
Wow.
The bottleneck hasn't disappeared, it has just shifted. We moved the wait time from the machine generating the data to the human desperately trying to interpret and trust the data.
So how do we design for this? How do we respect the Chronosapien Compact in a world of AI?
Nielsen points to very specific design patterns. One is optimistic UI.
Optimistic UI.
Think about when you delete a file in a standard operating system. It throws up a dialog box. Are you sure you want to delete this? You have to stop, read it, and click yes. It interrupts your flow.
Yeah, constantly.
Optimistic UI assumes success instantly. When you hit delete, the file vanishes immediately. But the system offers a highly visible, guaranteed undo button. It prioritizes the speed of human thought while providing a safety net.
That's brilliant. It honors that 400 millisecond perception rule. What about the recovery phase, though, when I come back to a project after a 3-day weekend?
You implement return recaps? The system shouldn't just dump you back onto a complex dashboard. It should present a highly condensed summary that highlights only the differences, the delta of what changed while you were offline.
Oh, I'd love that.
Since you were gone, 3 tasks were completed and 1 requires your approval. The user doesn't have to burn calories rebuilding their mental model from scratch.
And for AI?
For AI, you use confidence bands. You visually show the user the statistical uncertainty of the output. The AI might highlight a paragraph in green, signaling, I am 98% confident in this fact, but highlight a statistic in yellow, signaling, I am only 40% confident here.
So I know exactly what to check.
Exactly. Yeah. That tells the human exactly where to spend their precious cognitive budget checking the work.
This is a massive light bulb moment for how we treat our teammates. Let's look back at Big Sig and Lil Siggy during the inventory API crisis. Let's say Big Sig was in class all day, completely disconnected from the project. Lil Siggy discovers the core bug. The absolute worst thing she could do is forward him a massive 50-message Slack thread with server logs and just say, read below.
Oh, if she does that, she is violently violating his cognitive latency.
Right.
She is forcing him to spend immense mental bandwidth parsing a chaotic execution phase just to reach comprehension.
Exactly. So what a Sigma Scholar does instead is provide a human return recap. She sends one message using the inverted pyramid structure. Outcome first. Hey, Big Sig, the API is down due to a payment gateway loop. Here's the delta. I reverted the code to yesterday's build, so the front end is stable. Here's where I need your eyes. Can you look at line 42 when you log on? I am uncertain about the syntax.
That is breathtaking interpersonal empathy.
Isn't it?
She has pre-processed the chaos. She has reduced his interpretation overhead. She is treating his attention as a sacred, finite resource.
It's incredible how taking these rigid, structured concepts from user experience and applying them to human conversation changes everything. And that leads us to a really fascinating realization. To organize tasks and conversations with this level of empathy, you need a mental framework.
You do.
You need a way to visualize how your brain actually handles the barrage of daily friction. Which brings us to how elite professionals literally use computer data structures to cope with human chaos.
Yeah, we are moving now from the external architecture of software into the internal architecture of the mind. As technology has become ubiquitous, humans have begun using its structural logic to manage their own emotional and operational states.
Right.
We are specifically looking at how professionals use the concepts of stacks and buffers.
Let's start with the stack. I hear people say this all the time. Let me pop that off my stack, or my mental stack is totally full right now. But what is a stack in pure computer science?
Formally, a stack is a linear data structure that strictly follows a last-in, first-out principle, or LIFO.
LIFO, last in, first out.
The classic physical analogy is a stack of heavy ceramic plates at a cafeteria buffet.
Okay, yeah, those spring-loaded dispensers.
Exactly. You cannot pull a plate from the bottom without causing a disaster. You can only interact with the plate sitting on the very top. In computer science, there are 2 primary operations you perform on a stack. You push a new piece of data onto the top, or you pop the top piece of data off to reveal what is underneath.
And how does a computer's CPU actually use this?
It uses it to handle interrupts. If a CPU is running a complex program and suddenly a high-priority hardware interrupt occurs, say you move your mouse, the CPU cannot just abandon the program.
Right.
It takes its current state, all its current calculations, and it pushes them down onto the stack, saving them in memory. It then handles the new urgent mouse movement on the top of the stack.
And then when it's done,
Once that is resolved, it pops that task off, retrieves its previous state from the stack, and resumes the complex program exactly where it left off.
and that is exactly what Big Sig has to do in the lab. He is deep in a state of flow, writing a difficult function. Lil Siggy walks over with an urgent question about the client meeting tomorrow. He cannot let his brain completely delete the coding logic.
No.
He mentally pushes the code state into his cognitive stack, holds it there in his working memory, deals with Lil Siggy's question on the top of his stack, and then, ideally, pops it off and drops right back into the code.
Yes, but here is the critical danger. Human working memory is severely limited. A computer stack can hold millions of items. A human mental stack can hold maybe 3 or 4 complex items before it overflows.
3 or 4, that's it.
That's it. If Big Sig gets interrupted by Lil Siggy, and then his phone buzzes with a text, and then he remembers an email he forgot to send, he has pushed too many items onto his mental stack.
Oh, wow.
The bottom items degrade. He experiences a stack overflow. He loses his flow state entirely, and it will take him 20 minutes of cognitive recovery time to get back to where he was.
Which is why understanding this structure is so vital. If you know your mental stack is fragile, you protect it. You put on noise-canceling headphones. You tell your team, I am going deep for 2 hours. Please hold all non-emergency interrupts.
Exactly. And the second critical data structure we use to manage human interaction is the buffer.
I know the feeling of buffering all too well. Sitting there watching a movie stream, and suddenly the screen freezes and the little circle starts spinning.
That spinning circle is the visual symptom of a buffer emptying out. But the concept itself is an engineering marvel. In computing, a buffer is a dedicated region of physical memory storage used to temporarily hold data while it's being transferred from one place to another.
Okay.
It is absolutely essential when you are moving data between two devices that process information at vastly different speeds.
So if Netflix is sending me a 4K movie, my internet connection might fluctuate. It might be fast one second and slow the next. But my television needs a constant, steady stream of data to play the video smoothly.
Precisely. So the television builds up a reserve. It downloads a minute of the movie ahead of time and stores it in the buffer. If your internet suddenly drops for 5 seconds, the movie doesn't stop. The television just pulls from the buffer, absorbing the shock of the network failure. The buffer is a protective mechanism to absorb friction between unaligned systems.
And humans use buffers constantly. Our sources outline several types. We have financial buffers, having 3 months of rent in a savings account to absorb the shock of a sudden car repair so it doesn't destroy your life.
Right.
We have psychological buffers, morning routines, or meditation practices that build up emotional resilience before facing a chaotic workday. But the most important application for our Edward Little High School listeners heading into technical teams is the communication buffer.
This is where we return to the inventory API project crisis. Let's look at how bad news is delivered. In professional communication, especially when delivering negative information, experts advocate for the indirect approach.
Okay.
This involves starting the interaction with a buffer statement.
What exactly is a buffer statement in a conversation?
It is a neutral or ideally positive statement that establishes common ground, shows appreciation, or provides context before the negative delta is introduced.
To soften the blow.
Yes. It is designed to soften the emotional blow. You are literally providing temporary psychological storage to help the recipient absorb the shock of the friction that is about to occur.
So let's put Lil Siggy in the hot seat. She has been reviewing the API code, and she discovers that a junior team member completely botched the database architecture. The build is broken. A novice communicator would just walk over and say, your logic is completely broken. You just crashed the main build.
And if she does that, the junior developer's ego takes a direct hit. Their amygdala fires, they go into a defensive fight-or-flight response, and they completely stop listening to her technical feedback.
It's a total shutdown.
It is a catastrophic system failure in the relationship.
But Lil Siggy is a Sigma scholar. She understands human data structures. She walks over and uses a communication buffer. She says, "Hey, I was just looking through the database module. I really appreciate how quickly you got this drafted, and I can see you incorporated that new security protocol we talked about." She's building up the emotional reserve. She is validating their effort. Then she delivers the delta. However, it looks like the loop structure is throwing a fatal error in the main build. Can we sit down and look at the syntax together?
The difference in outcome is astronomical. The junior developer feels seen and valued first, which allows their prefrontal cortex to remain engaged when the bad news arrives. They absorb the shock without crashing.
It is literally embodied mathematics. We are taking the structural logic of how machines handle data and using it to be kinder, more effective human beings.
The phrase embodied mathematics is actually deeply rooted in cognitive linguistics, specifically in conceptual metaphor theory, pioneered by researchers like George Lakoff.
Oh, yeah.
Lakoff demonstrated that human beings are incapable of purely abstract thought. We naturally construct metaphors to link our physical, bodily experiences in the world to highly abstract concepts. We map the physical domain onto the conceptual domain. When engineers use structural metaphors like stacks, buffers, and equivalence classes, they are not just being quirky. They are utilizing mathematical narratives to organize the terrifying complexity of social friction. They are using logic to build empathy.
It is a beautiful synthesis. But as we move into our final major topic, I have to play devil's advocate. We have spent the last 45 minutes celebrating the power of technical jargon.
We have.
We've talked about how terms like modulo and orthogonal create semantic density, save bandwidth, and build trust among the in-group. But there is a massive looming dark side to this. What happens when this dense technical dialect escapes the engineering lab and hits the general public? What are the profound risks of jargonization?
The risks are systemic, and they are incredibly damaging. While jargon is an elegant tool for compression among peers who share the same mental dictionary, it creates an impenetrable fortress when used with outsiders. Linguists describe the resulting psychological effect as disfluency.
Disfluency. The opposite of flowing smoothly.
Yes. Processing fluency is the ease with which our brains decode information. When a non-technical stakeholder, a client, or a terrified patient, hears a term like orthogonal, heuristic, or latency, and they lack the mathematical background to instantly map it, it creates a massive cognitive roadblock.
They just hit a wall.
The brain has to stop, engage its slow, calorie-burning system to thinking, and try to guess the meaning from context. This disfluency doesn't just cause confusion, it actively breeds mistrust, alienation, and the overwhelming perception that the speaker is being arrogant.
And we see this weaponized all the time in the corporate world. Our sources point directly to the phenomenon of corporate speak.
Corporate speak is the dark mirror of technical jargon. When a brilliant engineer uses modulo, they are doing it to clarify a complex truth.
Right.
When a middle manager uses words like synergy, bandwidth, paradigm shift, or actionable deliverables in a generic meeting, they are rarely trying to clarify. They're often using jargon as a smokescreen.
Yeah, to hide the fact that they don't know what they're doing.
Exactly. They use it to sound sophisticated, to mask a lack of actual strategy, or to justify exorbitant consulting fees. It obscures meaning rather than compressing it. It is using language as a weapon of status.
And the consequences are catastrophic when we scale this up, especially with artificial intelligence. Let's look at the example of the financial AI chatbot mentioned in our sources.
That is a perfect, terrifying case study. A major financial institution deployed an advanced AI chatbot to help elderly customers navigate their retirement pension plans.
Okay, seems helpful.
But the engineers trained the AI on dense legal documents and financial white papers. When a confused senior citizen asked, "What happens to my money if I die?" the chatbot responded with a block of text about amortized fiduciary distributions and probabilistic actuarial tables.
Oh no, the user experiences total disfluency.
Total disfluency. And what does a human do when faced with that level of cognitive friction? They panic, they tune out, they abandon the interaction entirely, and they lose all trust in the institution that built the tool.
So let's look at the psychological mechanics of this. Why do our brains react with such intense hostility when someone talks over our heads? Why don't we just politely try to learn the new words?
To understand that, we have to look at a foundational psychological framework called the Elaboration Likelihood Model, or the ELM.
The ELM.
Developed by Petty and Cacioppo. The ELM explains exactly how human attitudes are formed and how persuasion works. The model proposes two routes of processing: the The central route, which involves deep, logical, calorie-burning thought, and the peripheral route, which relies on shallow cues and heuristics.
And which route we take depends on motivation, right?
Exactly. The ELM states that the impact of dense language depends entirely on the audience's motivation and ability to process the message. Human brains are evolutionary cognitive misers. We fiercely protect our glucose reserves. We do not want to engage the central route unless we absolutely have to.
Give me an example of high motivation overriding the jargon.
Imagine you are on an airplane, and the pilot announces that there is a critical failure in the hydraulic actuation redundancy system, and you must prepare for a crash landing.
Okay, that is heavy technical jargon.
It is, but your motivation to survive is absolute. You will push through this fluency, you will engage your central processing, you will listen to every word and follow the safety instructions perfectly, regardless of the dense terminology.
But what if the motivation is low? What if I'm just a casual user trying to read a software update's terms of service or an executive sitting through their fourth status report of the day?
If your motivation is low, your brain refuses to spend the glucose required to decode the disfluency. You default to the peripheral route. In this state, the style of the message becomes the deciding factor, not the substance.
Oh, wow.
Because the jargon creates severe processing friction, your brain interprets the message as too difficult, not worth the calories. You simply drop it. You ignore the message entirely, or worse, you instinctively reject the speaker's proposal out of sheer annoyance.
So I have to ask this directly. This is the most important question for our listeners at Edward Little High School. As our future Sigma scholars prepare to leave the classroom and enter the intense, multidisciplinary reality of the tech industry, how do they know?
How do they know what?
How do they know when it is appropriate to deploy a beautiful, mathematically precise term like orthogonal, and when they should just look the project manager in the eye and say, these issues are unrelated?
That question is the absolute crux of this entire deep dive. It is the defining test of a professional. The ultimate goal of the Sigma Scholar academic pathway is not just technical brilliance, it is interpersonal excellence. And the absolute core of interpersonal excellence is cognitive empathy. It is the ability to read the room.
Read the room.
True industry leaders are fundamentally bilingual. They possess two distinct dialects, and they know exactly when to switch between them. When a Sigma Scholar is deep in the trenches with their engineering peers, they use the jargon. They use modulo, they use delta, they talk about stacks and latency. They do this because it compresses complex thought, saves the team's mental bandwidth, and fosters a fast-paced, high-trust environment where everyone shares the same high-resolution mental map.
But the moment they step out of that trench,
The moment they turn to face a client, a non-technical stakeholder, the marketing department, or a junior team member who is just learning the ropes, they effortlessly, instantly switch gears.
they drop the jargon.
They strip away the academic math. They translate the structural concepts into plain, empathetic, universally accessible language. They understand that language is a tool designed to illuminate and connect. It must never, ever be used to alienate, obscure, or diminish the person sitting across from them.
That is exactly what separates Big Sig and Lil Siggy from the stereotypical brilliant but impossible to work with coder. They use language to build bridges, not walls. They know the math intimately, but they never forget the human operating the machine.
It is the ultimate expression of respect for the Chronosapien Compact. They respect the time, the bandwidth, and the background of every single person they interact with.
Wow. Okay, we have covered an immense, profound amount of ground today. Let's synthesize this journey. We started by exploring the fascinating semantic migration of mathematical operators. Words like modulo and orthogonal originating in the late-night hacker culture of the MIT AI labs and bleeding into our common speech, fundamentally serving as a linguistic compression algorithm for complex logic.
Yes. We then plunged into the biological reality of our minds, exploring the concept of mental bandwidth. We looked at the sugarcane farmers and the scarcity tax, recognizing that our cognitive capacity is a highly fragile, rapidly depleting resource that must be ruthlessly defended against stress and interruption.
We examined Jacob Nielsen's insights on UX, learning that the true bottleneck in technology is human cognitive latency. We walked through the latency stack: perception, comprehension, decision, execution, and recovery, and learned how to use empathetic design like return recaps and optimistic UI to ease the crushing burden on the human brain, especially the unpredictable era of AI.
And we discovered the beauty of embodied mathematics, seeing how borrowing structural frameworks from computer science, like the last-in, first-out stack and the shock-absorbing buffer, can actually make us infinitely better, more empathetic teammates. But we balance that by understanding the elaboration likelihood model, warning us against the alienating trap of jargon and the cognitive tax of disfluency.
But before we let you go, our expert has a final, somewhat mind-bending thought to leave you with. A look into the future of how we will work and talk.
Yes, drawing one last time from Jacob Yielson's predictions for the future of interaction. We have spent this entire hour talking about human and machine interactions measured in milliseconds, seconds, or perhaps hours. But as artificial intelligence evolves from a simple chatbot into an autonomous, goal-oriented agent, we are rapidly approaching an era where we will hand off tasks to machines that take a year or even a decade to complete.
Wow.
Imagine tasking an AI to discover a novel protein structure for a disease cure, or deploying an AI educational assistant that is contractually bound to guide a student's learning from kindergarten entirely through their college graduation.
Interacting with the system over a 20-year timescale. The latency phases on that are unimaginable.
Exactly. The question for you to mull over is this. As the scale of our technical interaction shifts from milliseconds to decades, how will our language, our slang, and our metaphors evolve next?
That's a wild thought.
Will we develop entirely new interpersonal vocabularies based on multi-year compute contracts? Will we resolve team disputes using terms derived from generational algorithmic handoffs and century-scale latency? The words we use will inevitably shift to map the terrifying and beautiful new reality we are building. What will your dialects be in the year 2040?
That is an incredible, profound thing to think about. To the Sigma Scholars of Edward Little High School, I want to address you one last specific time. Your technical proficiency, your ability to write clean code, to calculate complex loads, to engineer flawless databases, that is just your ticket in the door. It gets you the interview. But true power, true influence, and true success in this industry come from mastering the human element. The server room has a manual. The team room requires empathy.
Pay deep attention to the language you use. Pay attention to the invisible biological forces of scarcity and cognitive load acting on your peers every single day.
I invite you this week to pay close attention to your own mental bandwidth. Notice the tunneling effect when you are stressed by an exam, and in your next difficult team interaction, practice intentionally using a communication buffer. Soften the friction before you deliver the delta. Because while the diagnostic logs might give us a perfectly clean binary 0 or 1 answer for a broken server, navigating the murky, beautiful waters of human teams requires a much more sophisticated kind of logic. Thank you for diving deep with us.